Okay, so I have just finished up a little Kahoot that we did in class to study some practice on probability, and now I'm getting into two of the really toughest review problems because today's a review, tomorrow's a review of probability, and then we have a big test on probability, and that'll happen again not tomorrow but the next day. Okay, so we got a fair amount of time to review. So the first question I want to ask is, if I were throwing tennis balls into the trash can, and I was pretty good at it, I was a 90% free throw shooter, right away, 90% tennis ball shooter anyway, right away, if you know probabilities, you know we're probably going to be doing a binomial, because as soon as I say 90%, I already gave you a probability to do a probability. That's kind of a hint. It's probably one of these. C with two parentheses. Did you put a 90 and a 10? Good, then you're on the right track. And then this is always the most like possible number, and the possible number was 6. I took 6 shots, and I wanted to make how many of them? 5. So then this number goes here because I have 5 90%. Those are the ones that are likely to make it. And then the 10% are the ones where I'm saying I'm going to miss it. And there's how many of those? 1. Excellent. If that's what you typed in, you should have the right answer. But just double check, because some kids last hour were typing it wrong. See what decimal you had. What did you have? 3.5? 3.54? Anybody verify that? Okay, it looks like that's the right answer. And so if you got something different than that, you're probably typing that in wrong. Any questions on that one? Now, just think about that for a second. There's a 35% chance of that. Isn't there also a chance that I'll make 6 out of 6? If I were to phrase the question this way, what's the probability I make at least 5 out of the 6? Then what would you need to do? Find the probability of 6. Do it. This was the probability of 5 being made. Now let's do the probability of 6. And if I say at least 5, that means I'm going to make 5 or 6. And or is a hint to add. So here it is. 6C6. See if you can type it in faster than I can do it. And 0.1, choose 0, or to the power of 0 is really just a 1. And 6, choosing out 6. If I have 6 things, whoa. If I have 6 things, do you get that if I choose all 6 of them, there's only one way to do that? So I don't even need to type that in. So it's really 0.9 to the 6th power. And what is it? 0.088? Oh, no, okay, wait. Hold on. How much just for 6, choose 6? 0.853, or are you agreeing on that? No. 0.531? How many could say that that was what they think it was? Okay. It's not what I expected. I thought it was going to be a lower than 35% chance. But now that I think about it, I'm a 90% free throw maker or tosser into the garbage can guy. Then I should really make 6 out of 6 more than I should make 5 out of 6, because it's closer to 90%. I never thought of it that way. So, okay, I can buy that now. So now, is the final answer to the question 531? No, the question was, what's the probability I'll make 5 or more, which means 5 or 6, which means I add them if it's an or. So you should have said 0.885. So you probably round it to 0.89, right? About 89% chance. Now that makes sense. About 90% chance that I'll make 5 or 6 if I'm a 90% free throw shooter. That kind of actually feels like it makes sense for once. These can be challenging. All right. Now let's move to the second hardest kind, and some people think it's harder than the other kind, and that's where you have CC over C. All right, first it's just CC. The CC over C is a probability question, but a lot of times in this test, we aren't actually even asking you probabilities. We will say, how many ways can you? All right, so I'm going to do one where it's cards. And if you have any questions about like how many hearts are there, how many kings or whatever, you can ask me, all right? So first question is, if I'm going to be dealt 5 cards, how many different hands are there that have 3 kings and 1 ace? Remember, it's a CC because this is subgroups. Because I got a big group of cards, 52, and I'm dividing it into little subgroups like the hearts and the clubs and the diamonds. I wanted 3 kings and 1 ace. Now this is the tricky part. I only said that I wanted 4 cards, but it's supposed to be a 5 cards get dealt to you. Did you get you really needed a third C? Because if all you do is I have 4 kings and I'm getting 3 of them, and I have 4 aces and I'm getting 1 of them, I have only so far pulled out 4 cards. So then what you need is to get 1 more pulled out of what? Out of what? Well, it can't be the other 2, which were kings and aces, so it could be all the other things, which is 52 minus this minus this. 52 minus 8, which basically makes it like 50 minus 6, which would be like 44. Good. These are the kings, these are the aces, these are the other than kings and aces. Now, here's the things you should look for. Does this add up to 52? I think it does. And does this add up to 5? You see how they're supposed to add up like that? Okay, now let's do another one like that. Except this time, you need to quickly get that this doesn't just work for cards. It works for anything you have a big group, like 52, that's subdivided into smaller groups. Like, would you agree that since there are, well, how many people did we have in Kahoot earlier? 24? Okay, there's 24 of you, that we got some guys, some girls. That's subgroups. Or we could say some people with darker colored hair and some people with lighter colored hair. Or we can divide it into lots of different subgroups. Do you remember the one that was about defective things? That would be like everybody's got a calculator. Let's say one of your calculators is about to die. And they eventually do. So maybe one of yours is just about to die. We don't know which one, but I'm going to consider that a defective calculator. It's about to die on you. Then let's do that defective problem right now. How many different ways could I get, if I'm going to take 2 calculators off your desk, there's 24 of you, how many different ways could I get 1, if I grabbed randomly, if I get 1 defective one and 1 not defective one? Remember, out of the 24 of you, only 1 person has the defective calculator. Think of it as, it's sort of like a deck of cards where there's one of these and everything else is one of those. So it's like a CC question. I never said probability. I just said how many ways. You don't have to even type this in as long as you write down the right CC. So how many defective ones are there out there? 1. And for the purposes of this, did we want to choose 1? Yes. And then how many not defective ones are there? And don't say 24. 23. That's where a lot of people make their mistake. I'm glad you guys right away knew that. That's good. And if there's 23 not defectives, how many of those do I want? 1. There we go. That's how many different ways there are. And there's a lot. All right. So now, just add one little thing to say, what's the probability that out of all the things that I could grab when I get 2 calculators, what's the probability I would get 1 broken and 1 not broken? So how is it different than what we have already? It has to be over something. Divided by what? Okay, the bottom is always the totals. It's always the bigger number. You can't have a bigger number on top divided by a smaller number on the bottom, or you get something bigger than 1. That's impossible. So this has to be bigger numbers down here. So how many total calculators are there in the room? 24. And how many am I going to choose out of that group of 24? So that's the answer. I'm going to choose 2 out, and I wanted to get 1 that was defective and 1 not defective. All right, let's do one more of the defective kind of questions. All right, so let's say iPads. You know, at the beginning of the year, they hand them out to every kid. Let's say just in a grade level. Actually, let's do the whole school. There's 3,000 iPads in this school because we got about 3,000 students. Okay? So if you hand out 3,000 iPads, you've got to know there's going to be a few that there's something wrong with them, right? It's just going to happen. So let's say that there were 5 in the school that were defective. Kid gets it and it just doesn't work at all. Okay? Now let's say that Mr. Erickson walks into a room, a typical classroom like this. What's the probability that there's 24 kids and 2 of them are the kids that had the defective ones? So he's effectively choosing 24, and out of that 24, he's getting 2 broken, and less than that, or less than 24 anyway, not broken ones. So there's 3,000. So again, I'll say the numbers again. You have a 3,000 person school, each of which has an iPad. That's about 3,000 iPads. So let's say that there were 5 that were defective. What's the probability that Mr. Erickson were to walk into this room where there's 24 of you and 2 of the kids had defective ones? It's not likely, by the way. If there's only 5 in the whole school, what's the probability that 2 of them would be here? That's another way to say the question. Okay, first of all, if you know it's a CC over C, at least you have a good chance. And then, where did I say was a smart place to start a problem like this? The bottom. I like to get the totals first. I didn't last time, but I was kind of following your lead on how to do it. But I would say there's 3,000 here, and I'm picking out not 5. That would be picking out all the defective ones. I'm picking out how many kids in the sample that Mr. Erickson came in and said, oh, there's 24 kids here. See? 24 were chosen out. That's the biggest numbers. Now we subdivide it into defective and not. How many defective were there? 5. How many were there going to be chosen out of this group of 24? 2. How many not defective iPads were there? Excellent. And how many not defective ones would have been in that group of 24? All right. Now, last thought, you can look at this. Does this plus this equal that? And does that plus that equal this? Then you must be doing it right. How many of you had that set up right? All right, it's only about half of you, so don't feel too bad. That was a tough one. One more defectives question. Okay? Keep going bigger. Let's go to the whole United States. Okay, so there are about 300 million, I'm rounding here, it's actually more like 300, we'll use a closer number. 350 million people in the United States, or so. Okay? Now, just so you know, 5 million of them live in Minnesota. The rest of them don't. So it's not really defectives. We Minnesotans talk with a funny accent, though, so in a way, we're the defectives in this case. I'd like to think of us as special. All right, so anyway, the question is, you're at an airport, and it's in the Midwest somewhere, but it's not in Minnesota. And there's 100 people sitting in this big lobby in the airport. What's the probability you'll have 2 Minnesotans. I think I said 100. 100 people in this little lobby are chosen out of the whole United States. What's the probability that it's going to be 2 Minnesotans and the rest are not? Sir. There are 5 million Minnesotans out of the whole United States, which was 350 million for the whole United States. Minnesota total. Then, at our airport, we got this lobby where there's 100 people sitting in that airport. Now, if we made the airport in Minnesota, obviously they'd be mostly Minnesotans, but not all, for sure. But if we go to a lobby in some other airport, like let's say it's in Iowa or wherever, then what's the probability that 2 out of 100 were Minnesotans? Okay. It's CC over C question. So, where did I say to start? Bottom. How many total people are there? How many are we picking out in our subgroup? 100. Those are the bigger numbers. Yes? I believe you. Okay. Then, on top, I got to label my two things. It's not chocolate chip cookies and peanut butter cookies. It's not really defectives and not defectives. It's what? Minnesotans and not Minnesotans. My iPad's, or iPhone, my smartboard's freaking out. How many Minnesotans are there? 5 million. How many do we want? 2. How many non-Minnesotans are there? 345 million. How many of those do we want? And how do you know if you did it right? This plus this should equal this, and that plus that should equal that. How many have set that one up right? More than half this time. That's good. Questions, anyone? Yes, sir. That's the biggest number that we chose. We chose a group out, and that's the group where it was in the lobby. We had this smaller group out of the all United States, and it was just this 100 people in the lobby. Yes. Does the order on the top matter? If you reversed these two, that would be okay. Any other questions? Okay. Now let's do a blanks question, because that usually is another kind that it's like another strategy. You don't use CC over C. You don't use that binomial thing with the C in 2 parentheses. The blanks is a completely different way, but it's a really good way. So let's do license plates. Let's say that you got Minnesota license plates where there's 3 letters, and 3 numbers, and the numbers are first. Like, for instance, that. Let's say that's your license plate. Okay? What was the probability I was going to write that license plate on the board? Nothing fancy here like, oh, it's my license plate, so high probability. No, I'm just saying there was only one that I wanted out of, that's really the hard part, is how many were possible. The probability I was going to write that license on the board. Yes? In Minnesota, you can have repeated numbers and you can have repeated letters. This is blanks. Notice I didn't draw any blanks yet, but I will now. Do. One for each spot. So, how many choices for this spot? I had 10 choices for that spot. Times, why am I not going to decrease it to 9? Because I can repeat things. So if I pick a 4, I can have the 4 again in the next spot. So I have still got 10 choices, and 10 choices, and 26 for letters, and 26, and 26. There you go. 1 over all that. An incredibly small probability. All right, so you move the decimal over 8 spots to the left. So it'd be 0.00000000. And then what was the first number? 5 is probably good enough then. That's not likely. Okay, I'll give you a different one. Same thing on the bottom. I'm actually going to leave the bottom alone. So my question is, now it's not the probability I was going to pick that license plate, but the probability that the license plate would have a repeat in it. Either a repeated number or a repeated letter. The probability it would have a repeat. Actually, this one will get way too complicated. Okay, wait. I'm going to change this. Sorry. I'm going to make it 1 letter and 2 numbers. Like a much smaller license plate. Okay? Like a letter and then 2 numbers. Then, first of all, figure out what are all the possible license plates now. Much smaller number. And then, what's the probability of a repeat? And can you repeat a letter if you only have one? So then it's really just a repeated number. Remember, think of this as choices and blanks. All the things that could happen go down there. The thing you want to happen goes up here. Now really think about this one. How many choices do I have for this spot if this? Probability you're going to have a repeat number on your little mini license plate. At least everybody should get the bottom right. Did you get that anything was possible in the first place? So therefore there was 26 here, 10 here, and 10 here. You might say, but you said a repeat. I said, what's the probability I'll get? I want to get a repeat. That's what I want. But I said I didn't say that you could only have repeats. Anything was possible. So that means you can repeat. So therefore, I can have the 10 and the 10. Okay. So then what I wanted was, does this have anything to do with the letter really? Okay, so isn't there still 26 choices for what letter to use? So now ask yourself about the choices. And then for the first number, does it really matter what number I pick? No. So therefore, how many choices? 10 choices. For the last number, does it matter what I pick? Yes. Because I already picked a number. I don't know what it is, but I picked one. So I only have one choice if I want it to repeat. How many of you did it right? That's the answer. Do you get what I'm talking about there? Once you picked a number here, you had any choice you want there. If I want it to repeat, then that I only have one choice for because it has to match this other number. All right, and then I could do some fancy canceling. Watch. Cancel, 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 cancel. The answer is 1/10. Sir. Correct. If it's only one letter, can you repeat it? No. If I put an L on there, you can't repeat it because there's only one spot for letters. Nope. Yep. So like here would be a winner. I got L99, then you got one of the repeats. Something that was repeating was a winner. Oh, to get L25 issued again. I got you. But in the state of Minnesota, they don't give you the same license plate as somebody else. Any license plate thing, that's kind of the point of them, is your license has got to be different than hers, is different than his. On that license plate, did you know that there's a certain kind of license plate that is special?
There's one that's just white.
Yes, sir.
Is there a Egypt to go higher?
Yep.
What's the plate?
It
What's the W?
used to be a W. They called it a whiskey plate. And if your license started with a W, the first letter was a W,
You had two or more.
that meant you had problems with DWI. We'll just say it that way. And they won't just, I don't think they give it to you for one mistake on that. Probably two. Or a really bad one. Like you were really, really drunk or whatever. So if they give you a whiskey plate, it's kind of subtle in that a lot of people don't know that. But once you know that, I bet you'd be curious if you happen to look down the highway and you're like, ooh, there's a W plate. And be like, ooh, that person's at DWI. There's a bunch of them. Watch out for them. And really, it's not for the public, though. Otherwise, they would make a bigger deal about it. It's more for the cops. Because if the cop sees a whiskey plate and he's driving kind of funny, oh, they're going to pull him right over. Because they know he's already had problems with this. Let's make sure he's not doing it again. Yes? Tax exempt, yes. There are all kinds like that. But as far as I know, there's only one special letter where if it starts with that letter, which is a W, that's a naughty plate. But at least it doesn't say like, it's subtle, like it's just a W. Most people don't know, and it's not like you got the red mark of death on your license plate or something. Drunk 1, drunk 2, drunk, yes. I bet you that's one of the misallowed ones, along with a few others I'm sure you can think of. 3-letter combos that aren't exactly what you'd want on your license plate. But I have seen fat before. They don't take that out of the running. But yeah, you can imagine a couple other F words that might not be so good. Anyway, so okay, so that's blanks, and I think that's enough. I think your brains are pretty much full. So we do have a review day tomorrow too, but this has been a lot of probability. This test will be the one chance you have to retake the last 2 probability tests. Now, most of you did really well in the second one, but some of you didn't do so well in the first one. So you may want to take this chance to do well on this test on not tomorrow, but the next day. All right, so tonight's homework, for those of you that are not with me right now, I should show it to everybody at once here. I'm going to pause for a second while I pull that up. Come on. Okay, so if you were, I told them before they left here what their assignment was, but I'll tell you now. We're doing the top probability worksheet. It's called Lesson 6 Probability Test Review. There was more than one in the Schoology file. You're doing the top one. And then you're allowed to skip the last 2 questions, 10 and 11. And that's all I got for you for today.